Welcome to Fun with Physics. This is a continuation of the presentation I made last time. And what I want to do is take a closer look, hopefully a little bit better presentation, connecting the actual throwing process to the simulation. And again, what we're looking at was Brent had said before, of course, linear momentum converts to rotational momentum in the body. Legs and hips work like pistons and rods. Now, last time I showed you the setup that I had to show the piston and rod setup. And I'm starting off right now with everything in line. And the reason I'm doing that is I want to it gives a better graphic analogy between what's going on with the pitcher. This is the actual snapshot just before foot plant, or as the pitcher is going into foot plant. And the relationship between the simulation and the picture is such. Here's the force that's being applied here, which would be the force coming off the rubber. This little arrow here is 50 pounds force. Extension of the leg, this represents extension of the leg. Connection to the front hip joint, connection to the front hip joint, connection to the back hip joint, back hip joint, and front hip joint. We got a little bit of a problem here. If you go back to the flywheel, rotations are taking place around this axis right here, which would be the center of the hips. That's not where foot plant is taking place. Foot plant is or I should say, this is the fixed point on this simulation, is the center of the hips. When players going into foot plant, not to have a true analogy or more meaningful analogy, your anchor point for the front hip has to be here, which would correspond to this point here. So just to refresh, let me go back and we'll run this. And I want to run this in real time. So if we run this, let me reset this to the, remember we have to have an offset angle. Doesn't work without an offset angle, so we'll set the offset angle to 45 degrees, which we have here. And now we'll run this to show you where we were. There's our reciprocating engine. Okay, now you can see that rotation's taking place around this center point right here. Okay, so let me stop this and reset it, and let me go back to 0, which is representative of what's happening when the player is going into foot plant right here. So right here, this is what's going on. Now let's take our anchor point and we're going to remove it from here. Oops, didn't want to do that. Sorry about that. We want to take this anchor point here and remove it and re-establish the anchor point right here. This would correspond, here's your back hip joint, here's your front hip joint coming into foot plant with this force. Now let's see what's going to happen. Ready? Go. Oops. Stop. What did I do here? Yes. Okay. Sorry about that. Let me do this. Re-anchor this. Oops. Oh, I know what I did wrong. Run. Again, we're collinear. Remember what happens when we're collinear? Nothing happens when we're collinear. Alright? So, and it's good exercise to show you what happens. I have to create an angle here. Guess what happens though when I create the angle? You're going to find something interesting, I think. So let's do this. Remember our angle that we need? We're going to do it. 45. Okay, there we go. Now, I don't know if you saw this, but look what happened to the center of the hips, and this becomes even more dramatic. Wobbling. That's a very offset. And what I mean by this is what would be happening is if this anchor point and you were converting around that anchor point and it was simply because of the momentum crashing into the front foot, what would happen is the hips would displace quite violently this way, either translate this to this side or this side. Again, I'll run this. You see what happens? So the point being, and this is what I've said for years and years and years, attempting or thinking that you can convert linear straight line motion off the mound with the foot plant acting as the arresting pivot point agent isn't what's happening. It's not what's happening when you throw the baseball. It's as simple or as complicated as that. There's something a whole heck of a lot more going on, or a whole heck of a lot different. Until next time.